Welcome young friends. You are welcome to our course Manufacturing Processes 2. Now, we are going through module number 4, which deals with general purpose machine tools. Our lecture is this is number 2 under module 4, lecture number 4.2. Today, we shall deal with kinematic systems and operations of milling machines. Last time we finished drilling machine. Now, what are the specific instructional objectives? After completing or attending this lecture or lesson, the students will be able to state the basic functions and purposes of using milling machines, then classify milling machines and illustrate their configuration and applications, visualize kinematic system of commonly used milling machines and explain its working principle. Fourth, show and briefly describe the various applications of milling machines using different types of milling cutters. Now, basic functions of the milling machines. Milling machines, like any machine tool, what is the function of machine tool? Functions of machine tool, any machine tool, are to produce geometrical surfaces. That is a machine job which is bounded by some geometrical surfaces like flat surface, cylindrical surface, then contour surface and so on. Similarly, the milling machines are used to produce flat surfaces in any plane, the vertical plane, in horizontal plane, in an inclined plane. So, in various planes they will produce the surfaces. Then helical surfaces. So, helical surfaces are required say in gears or say drills, milling cutters, reamers and so on. Surfaces of revolution. Generally, the cylindrical surface or revolution are produced by turning, but by milling cutters also we can produce these surfaces of revolution in certain situations. Now, milling machines also produce contour surfaces of various configurations like cams, then threads and so on. Now, before we go into the milling machines, their classification etc., let us be familiar with two basic principles of milling. One is called up milling and one is called down milling. Now, this up milling and down milling concept. Now, this is the milling cutter, cross section of the milling cutter, slab or plane milling cutter, which rotates in this direction, and this is the work piece. Now, this will be moving in this direction and the cutter will rotate in the opposite direction, and this will remove a material. That means, the forces will act in this direction, main force. In down milling, the job rotates in this direction, the work is also fed in this direction. So, the force will act downward. Now, this is up milling and down milling. What is the basic difference? This has to be understood. One is technical difference, one is applied difference. Because of the force going up, one of the component of this force will tend to lift the job from the fixture or jig. So, this situation needs strong clamping. In down milling, the force acts in down direction, so the clamping will be more tightly performed. But the problem with this down milling is, if there be any backlash in the screw thread and the nut thread, then there will be a danger. Since it is going up, there is a component like this in this direction. So, job will be always pushed outward from the cutter, but in this case the job will be pulled in towards the cutter. So, if there be any backlash in the screw etc., this will be more problematic. So, this has to be taken care of. Now, the major uses of milling machines: making flat surfaces in horizontal plane, in vertical plane, in any inclined plane. Then making slots and steps. Now, what does it mean? Say slots, this is a surface and you make a slot. So, this is called slot, okay. And then a step. What is step? There is a surface, now you make one protruded step. So, this kind of surfaces can be produced by milling. Then coming to slitting or parting. There is a parting a plate into two pieces or a strip into two pieces by just a cutting action. Now, rotary turning. The turning is done in a lathe like machine by single point turning tool, but in some cases if required, this turning operation, that is production of surface of revolution, can be done by rotary cutting tools which looks or behaves like milling cutters. That will be explained. Making helical grooves or surfaces. Say when we make some cylindrical cam, it needs some helical surfaces. The flutes of the drills, the helical surfaces, and the milling cutters itself, we need the helical surfaces. So, helical gear, we cut the grooves by helical groove by special milling cutters. Long thread milling and short thread milling. Threads, screw threads can be produced by milling cutter. One is called long thread milling, like long screws or press screws are manufactured by milling cutter, and another, this is a very short threads of say small screws or bolts are manufactured in mass production by another milling cutter, called the process called short thread milling. This will be discussed in detail. 2D contouring, for example, the cam profile, the cylindrical cams or plate cams especially Archimedes spiral cam and any profile cam, and 3D contouring like say die cavities in die, mold, press mold, or say injection molding, cast mold, and all these molds cavities, particularly 3D type, are manufactured by special milling cutter in milling machines. The cutting teeth of gears, worm wheels, sprockets, etc. These are done by special milling cutter in milling machine. Making flutes, say in drilling machine, gassing, etc. in drills, taps, reamers, hobs, etc. Hobs is a worm basically, isn't it? So, here you see this is a hob. Sorry, this is a worm like this, and now if we just cut slots like this, then the cut slots, then we produce the milling, the cutting edges by, this is called gassing, which can be done in drilling, in taps, in reamers, in hobs. This gassing is nothing but grooving. These are again done by milling cutters in milling machines. Now, come to classification of milling machines. Now, milling machines are very versatile machines and can work large number of type of works by using various types of tools. So, these milling machines are of different type and cutters are also very different type. So, they need to be classified, okay, according to several aspects. Now, when we consider the classification, according to what we should understand? Say first say classification with respect to according to purpose of use. Again you remember, this can be general purpose, single purpose, or special purpose. General purpose means any work on any job of any size, any shape by any milling cutter, wide range of milling cutters. So, this is most versatile, these machines, most commonly used, but these are non-automatic and used for very small lot production or piece production. This is not a mass production machine. Now, single purpose, only one kind of operation will be done repeatedly, say only turn milling, only turning by milling cutter, say only thread cutting by milling cutter, or only producing cams by cam milling cutter, or slitting, say parting only. So, this is single purpose, these are semi-automatic and used for small lot production or batch production. Now, special purpose milling machines, these are automatic milling machines, where a definite number and type of operations are done repeatedly over a long time with certain attachments or systems, special systems. This is used for mass or lot production, these are automatic. For example, short thread milling, die sinking, duplicating machine, duplicating production, etc. These are automatic. Now, classification of milling machines according to configuration of and motions of the table and bed. Now, here you can see that this is a milling machine, very ordinary common type of general purpose milling machine, and this is the bed, okay, on which this is the table. Now, this is the milling arbor shown over here on which the milling cutter is mounted, okay, and this is knee type according to configuration, okay, configuration. Say first is knee type. So, the bed looks like knee and it is resting on a screw, static screw, and guided by the vertical guides. So, this bed can move up and down. On the bed, the table can move in along x direction forward or backward and along y direction, that is towards the operator and away from the operator. So, this is longitudinal feed, this is cross feed, and vertical feed is given on the bed, and on this cutter rotates only in one position, and that is mounted on a horizontal axis milling arbor. Now, on the bed the table moves, as I told, in x direction, y direction, and the bed moves along with the table and job in the vertical direction. So, this gives feed motion of the job in x direction, y direction and z direction. These are non-automatic and these are piece production or batch production type. So, this is very common use. Now, come to bed type. This is the bed type. Now, this is the bed. Now, this bed is very robust and rugged and rigid. It is not resting on a screw, it is resting on a base, solid base. So, this is a very strong rigid machine, and the cutter is mounted on the vertical axis spindle, and the cutter may be either say end mill type cutter or face mill type of cutter. This is more powerful and this can work at a faster rate. This is a heavy duty and robust, mostly vertical spindle, but this can be slightly tilted in some machines, and vertical feed is given to the milling cutter. So, the longitudinal feed is given to the table, cross feed is also given to the table, okay, and the vertical feed is given on the cutter. Now, come to planer type. The plano miller, actually this is a very large machine, rather largest milling machine of its kind. Basically, it looks like a planing machine. You see, this is the vertical rails, and there is a horizontal rail maybe, and this is the bed on which the table moves, on which the job is mounted. Instead of single point cutting tool or planing tool, this is milling cutters. Say large number of milling cutters, maybe up to 6-7 milling cutters can be mounted from this milling heads, which can be mounted on the vertical column or on the rail. So, the bed which requires a number of surfaces to be made, say horizontal surface, inclined surface, vertical surface, like that. So, this will be done by various milling cutters, and all these milling cutters will be mounted by number of unit heads. So, large number of milling cutters, even 8 milling cutters can work simultaneously, and the job will be travelling slowly. So, this is called plano miller. It is a high productive machine used for piece production or batch production. Large jobs having several parallel flat surfaces like lathe bed or table of grinding machines, planing machines, these are machined in plano miller. Plano miller, more than one cutting or tools are working simultaneously. So, one tool is here, one tool is there. There will be few more tools from different positions, vertically or inclined or horizontally, like that. The production is fast because of several cutting tools work simultaneously. Now, this rotary table. In the rotary table, this is the table, okay, on which the jobs are mounted. Maybe number of more than one jobs may be mounted, and that will keep on rotating about the vertical axis. And there are two spindles. On the spindles, milling cutters are mounted. So, the table will be moving and job will be done, and this entire table can move along the cross feed also, and a cutter can move vertically up and down. So, this is the structure is open on one side or both side, it can be closed type, high production rate, and work table rotates, one more vertical milling spindles, one or more. So, there are two shown here, there can be more than two even, either 1, 2 or maximum 3. So, these are first production machines. Okay. Next, come to the classification of machine tools according to spindle orientation. Now, you see the cutting tool is mounted on either the milling arbor, which is normally horizontal, or it is mounted on a vertical axis spindle through a collet or some adapter. Now, here according to the spindle orientation, what is the direction of the spindle? First of all, you see the horizontal arbor type. This is the most common type. Here you see this is the milling machine it is a knee type milling machine. Okay. This is the bed on which the table moves longitudinally and cross manually or automatically, and this is the arbor, horizontal arbor, on which the cutter is mounted, and axis is horizontal, and the job is mounted on certain device, either vice or a milling head or indexing head, and then all the feed movements and x direction, y direction and z direction through the table can be given. What are the characteristics? Hollow, plain or disc type cutters are used. The cutter should be hollow, so that it can be mounted on the arbor. Bed is usually knee type, as I told, used for non-automatic, because very versatile non-automatic machine, but very widely used for piece and batch production. The work table, now the work table, this work table here, this work table can be rotated slightly about this axis. This is a swiveling arrangement, say up to 30° plus minus, it can be tilted depending upon the requirement. So, it is stated that the work table may be or may not be swiveled in the direction of feeds along XYZ directions. In addition to XYZ direction feed, we can have another slightly a rotation within a small range of angle. Okay. Then again, according to spindle orientation continued, vertical spindle. Now, here you see that this is the spindle, okay. This is the head, milling head, this is the spindle on which the cutter is mounted here, and this is the workpiece which is mounted on the table, and table is mounted on the bed, and this bed can be a bed type or it can be knee type, but main thing is this axis of the spindle is vertical, and the what kind of cutters are mounted? These are either end mill type or shell mill type or face milling type. Later on you can see what are the different types of cutters. Now, the vertical spindle characteristics, end mill or face milling cutters are used. Spindles are always vertical. It may be the bed may be knee type or bed type. The table may have one additional swiveling movement. This can also have some swiveling movement. This table can be slightly rotated about this vertical axis, say within plus minus 30 degree. That improves the workability of the machine. Now, universal head type. What is universal head type? For the name implies it is highly more capable. Here you see that this is the axis of the arbor, and milling cutters can be mounted on the arbor like this. But there, if we have one attachment like this, now this is the axis of the cutter. So, this is the cutter, is a face milling cutter. Workpiece is mounted on this vice, and vice is mounted on the table, okay, and is a knee type machine. Now, this axis of the cutter can be horizontal, can be vertical, and it can be tilted also. About this axis, this can be tilted. So, this can be tilted like this. So, this is the vertical axis and it can be tilted, but in this machine is more versatile. Here you can see this is the axis of the arbor, and this can be rotated about this axis, this is the cutter, and then this can be rotated about this axis also. So, it is much more versatile. So, the spindle can be tilted about around x axis, around y axis also. It is much more versatile. In addition to this system, where you can mount say cutting tools like say end mill cutter, shell mill cutter, face milling cutter, you can also have another spindle for arbor on which some disc type cutter can be mounted. So, this is a more versatile and capable machine. Now, come to according to automation or degree of mechanization, according to automation or mechanization and productivity. Now, this machine shown over here is called hand mill. Hand mill is the most primitive milling machines. Everything is manually done and very low capacity. The size is very low. The job size will be also very small. Productivity is also very low, and quality will be limited because everything is done manually. Both the machine and the jobs are small in size. All operations, including the feed motion, is also done by this lever, which will be oscillated manually. Used for piece and batch production, very slow production, not very accurate, and planar and rotary table type. Sorry, this is the end of it. Now, hand mill is one most non-automatic and non-productive. Next comes planar or rotary table type. This planar and rotary table type are little more highly productive and has got little degree of mechanization, slightly mechanized, but highly productive because of the power and the rigidity and robustness which allow large depth of cut, feed and cutting velocity that make it productive, though slow working, but it is productive. Now, semi-automatic. In semi-automatic, this is semi-automatic machine. Semi-automatic. Tracer controlled copy milling. Now, tracer controlled copy milling, suppose you want to produce a cam with a lobe. Now, this will be done by you take another blank and then you take the one follower and the cutter. So, this will follow this path, this profile, this cutter will follow this, also follow this path and produce the cam. So, it is exactly just like copying, you take a masterpiece and that will be copying. So, this is the cutter and the blank will be mounted here on a shaft, and this is the tracer which will be travelling along a masterpiece, and the movement of this one, say XYZ movement, X and Y, these two movements will be taken by this cutter and this will reproduce the job. If this be like this, this will be also produced like this. Okay. Now, this is low to moderate rate production, medium rate production, piece of batch production is possible, used for making cams, mainly dies using masterpiece, etc. Now, next is automatic, which is very fast production, much more, that is, this is semi-automatic which I described. Now, this is automatic. In case of automatic, the work will be much faster production, and machines are small but automatic and they are highly productive. For example, say short thread milling on say a bolt, small screws, and you have to produce the thread. Okay. This will be done very quickly at very fast rate, and this is a special milling machine, automatic machine. Then CNC. What is the full form of CNC? Computer numerical control. This is a modern machine, modern milling machines. Now, this is automatic, no doubt, but this is flexibly automatic, where the job can be changed very quickly and the change in the product will be taken care of by writing a program, a suitable program, and that program will enable producing one job to another job to another job. So, this flexible automation will cause changeover from one product to another, less effort, less time and less cost. So, this is very good for flexible automation. So, changeover cost, effort, time will be very less, and this is the characteristics of CNC machine, is a modern machine, milling machine. Complex shape jobs can be easily done, much better than other machines, lesser maintenance and requirement, because these machines are computer controlled electronic hardware and software. So, the mechanical number of parts are very small. So, wear and tear will be much less and maintenance requirement will be also much less, and lesser number of jigs and fixtures, or no jigs and fixtures are required at all sometime. So, these are the advantages of the CNC milling machines. Now, this is another improved version of CNC milling machine. CNC milling machine does only the milling activities, but this is a machining center which enables, in addition to milling work, drilling, boring, counter sinking, tapping, various kind of work can be done. So, drilling machine, boring machine and milling machine are combined into one. So, this is called machining center, all right. This is called, sorry, this is the machining center, all right. In the machining center, this is the machining center. Here you see large number of cutting tools are placed in a bank called magazine, and this is the spindle where the tools are fitted and one after another tools are replaced. Okay. the replacement of the tool or change of the tool is done very quickly, maybe within 1 second, and this is very versatile flexibly automatic machine which can do lot of drilling work, milling, boring, etc. Much more versatile and productive. Tool magazine is there, up to 250 cutting tools can be preserved, and it is characterized by having ATC, automatic tool changer. So, there is a device which enables very quick change of cutting tool from the spindle to the bank. So, this is most modern, very modern machine tool. Now, come to the kinematic system. Kinematic system of common type milling machines and its working principle. This is very versatile. Now, as I told that there are different types of milling machines, maybe say a few dozen types of milling machines, all right, and different types of milling machines will have certain difference in their kinematic system. What is kinematic system? I remind you, kinematic system is comprised of number of kinematic chains having number of mechanisms. So, this is a kinematic chain. What are there? From the motor, power goes from the belt pulley system, then a clutch, from clutch to worm and worm wheel, or it comes to the speed gear box comprising large number of cluster gears, then comes to the spindle. So, this is how all the movements are accomplished by number of kinematic chains, and each kinematic chain possesses number of mechanisms. So, the kinematic structure deals with transmission and transformation of motion from the source to the this is the cutter. Okay. Now, the first motion has to be transmitted from the motor to the cutter, rotation only. So, this will go from the belt pulley, then the clutch, from clutch to the shaft, from this shaft to this shaft, from this shaft to this shaft, then from this shaft to this shaft. This is the spindle, and in the spindle the milling arbor is fitted, on the arbor the cutter is fitted. So, this rotates only, and this can be made to rotate at different RPM by changing the speed with the help of this cluster gears. This is called speed gearbox, where the clusters are shifted to change the position. And now, the job has to be moved, feed motion. How many feed motions are there? There is a longitudinal feed in this direction. Let me clear it. This is the cutter, this is the job piece, this will have some longitudinal motion, then a cross motion, and this has to move up and down as and when required. So, 3 feed motions are required. This is X, this is Y, and this is Z. How this will be accomplished? Where from the motions will come? See, from this spindle, from the lower shaft where the power comes from the motor, this is coming to this shaft, okay, this shaft. From this shaft it is reduced by worm and worm wheel, because feed motions are very low. So, it is coming to this shaft with, again there is a reduction by worm and worm wheel. By cluster gear the motion is splitted into 2, then again it is splitted into 3, then again splitted by 3. So, 3 into 3 into 2, total 18 number of speeds by which this shaft can be rotated. Now, this motion is transmitted to this shaft with the help of this mechanism called telescopic shaft and ended with 2 universal joints. And now, this worm and worm rotates this worm wheel that rotates this shaft. So, power comes into this gear, from this gear to these 2 gears which are freely mounted. Now, by operating this clutch left and right, this shaft can be made to rotate either clockwise or anti-clockwise, and that power goes into this screw through these bevel gears. So, this screw, this lead screw will rotate, resulting the longitudinal feed of the table along with the job. Now, the power can also come into this clutch, from this clutch to this gear or this gear, from these 2 gears either clockwise or anti-clockwise, the power will come into this shaft. Now, this gear can be connected here or there. If it is connected here by shifting, then this gear will rotate and this screw will rotate, this nut will move, along with the nut this whole thing will move crosswise. So, this is how cross feed is obtained. You can do it manually also. How is the vertical feed of the table obtained? The power comes into this shaft, okay, this shaft. Now, this gear will be connected with this shaft. So, this shaft will make this shaft rotate. So, this bevel gear will rotate this bevel gear, all right. So, this is a nut. So, this nut will rotate against the screw, this screw is fixed. So, this nut will move upward and downward depending upon the direction rotation. So, direction rotation can be controlled by operating this clutch. So, the whole bed can be moved up and down along with the nut, and this will enable movement of the job vertically upward downward. This is how all the motions are done. Now, this motor is used for quick traverse, for setting the job. For setting the job, so the table has to move sometime very quickly to the cutter, and that is done by with the help of this motor, with the help of this overrunning clutch. This is called overrunning clutch, all right. This is the shaft of the motor, and this is when this worm rotates, then it rotates the worm wheel. That worm wheel when rotates, these 3 rollers get jammed into this space, friction jam, and then this disc is rotated, transmitting motion to the shaft. Okay. Now, when it is not required, this motor is operated at high speed, this will rotate directly, and that will help get all the feed motions rapidly, all right. This gives you this quick traverse motion, this one and this overrunning clutch together. Now, come to various applications of milling machines using different types of milling cutters. Now, you can see that what are the various types of milling machines exist, like lathes, okay? And along with the milling machine, there are different types of milling cutters, and with the different type of milling machines and milling cutters, wide range of work can be done, various types of work that you have already observed. Now, you can see again with the cutters. Now, classification of milling cutters. Classification of milling cutters. Now, as I told you, the milling cutters are of different types. Basically, there are 2 classes of milling cutters. One is called profile sharpened milling cutters, other is called form relieved milling cutters. Profile sharpened milling cutters, they produce only flat surfaces irrespective of the tool shape. Whatever the shape of the tool, the surface that is produced or surfaces, those are all flat. Suppose even if it produces slot like this, it produces one horizontal surface and 2 vertical flat surfaces. Okay. So, that is one, it produces a flat surface. Second, plain milling cutters, for example, it can be straight fluted or helical fluted. The example will be given immediately next. Side and slot milling cutters is a disc type. Slitting saw or parting tool is also disc type. End milling cutters, straight fluted or helical fluted. Face milling cutters, which are large cutters, which are used for making flat surfaces in large jobs. And second one is the form relieved cutters. These are form cutters actually to produce job to different forms of the surface, like say cam surface, like say Archimedean spiral cam or say involute cam and all these things, say, and slots, grooves, gear teeth and so on. In this case, these form relief cutters are characterized by the fact that the job profile that you will obtain is nothing but the replica of the form of the tool. For example, suppose you want to produce the gear tooth, okay, the gear tooth. How do you produce? We remove this material from in between. So, the cutter shape will be like this. This is the shape of the milling cutter, it is a disc type cutter. When this will rotate, this will remove material. So, you will observe that the form of the tool is a replica of the profile of the job to be developed. That is the characteristic of form milling cutters. For example, form cutters, T-slot cutters, gear milling cutters, spline cutters and many others. Now, let us see the different types, various applications of different milling cutters we are passing through. Now, first let us start with uses of profile sharpened cutters. This is a profile sharpened cutter. It looks like a cylinder, hollow cylinder. It is a hollow cylinder. This is the axial view and this side view, but these are the teeth. Okay. Here you can see the teeth. These are helical fluted. These are helical fluted. How they actually, originally this was a disc like. Now this material has been removed by what is called gassing, and then these cutting edges are developed. These are sharp cutting edges are developed because of removal of these materials, and this is called gassing. So we produce teeth 1, 2, 3, 4, 5, 6, 8 teeth. So these are the teeth. Now these teeth can be straight also. If it is straight, these are called straight fluted plain or slab milling cutter. If it is helical, it becomes more effective, then this will be called helical fluted plain or slab milling cutter. So the job will be moving in this direction, cutting tool will rotate in this direction, and this material will be gradually removed like this. Gradually it will remove by the tooth one by one by rotation. Next is, now still we are discussing profile sharpened cutters. Okay. Profile sharpened cutters which produces flat surface. Now end mill and shell mill. What are the material of the slab milling cutters in the previous case? Mostly high speed steel, but this can be carbide also. Why high speed steel? Because these milling cutters are intermittent cutting tools. So there is a jerk or vibration, and therefore the cutting tool material should be tough enough, and high speed steel is very tough. And you see the geometry of the milling cutters are very complex, and manufacturing of this thing is very difficult. So the high speed steel can be easily formed like forging, then rolling, machining, heat treatment, grinding, and all these things are very easy to do, and it is very tough and strong. So most of the milling cutters are generally made of high speed steel, but sometimes carbides are also used, either in the form of brazing or some sintered carbides are clamped, and if clamped it can be uncoated carbide or it can be coated by titanium carbide, titanium nitride, etc. Now the configurations and applications of end mill cutter. End mill cutters, nothing but it looks like a rod. Okay. It looks like a rod, this one, and at the end there is a cutting edge developed, and this produces, what are the applications? Here you see the face milling. Here is making a pocket which is made of number of flat surfaces, and this one is angular milling. It produces this flat surface, say this flat surface is making, and this is making slot. This is a slot. Okay, this is making a slot. Now this is shell milling. These end milling cutters are generally small in size, maybe say 1 millimeter to 40 millimeter. But when the diameter need to be large for the purpose of making, machining large flat surfaces, then we use shell mill cutter. The shell milling are different from end mill in the fact that the cutting portion of the cutter is a separate piece, and that is clamped into the spindle through an adapter. Okay. This is slightly larger in diameter, is also hollow, which is fitted into the adapter. This is also used for flat surface and the larger surfaces. Then use of profile sharpened cutters, again face milling cutters. Now face milling cutters are really, this is a profile sharpened cutters which produces flat surface, but what is the difference? Difference is, this is industrial type, and very wide surfaces can be produced, very long and wide job surfaces can be, flat surfaces can be produced, and the diameter of the cutter, here you can see, this is the principle of cutting action. This is the cutter, this is the cutting tooth, and axis is vertical, it rotates at high speed and job moves in this direction, and the material, this is the surface produced. So materials are getting removed. Now this shows an example. Okay. This is the cutter, and these are the cutting tooth. Okay. These are carbide, clamped carbide, and in this case these are all coated. Have you seen? And this is producing this flat surface, and this is the original surface, and this is the flat surface it is producing, and is removing material very quickly. These are the chips. Okay. The diameter of the cutter may vary from say 80 millimeter to up to 800 millimeters, such a large value, and this kind of cutting tools are used for making flat surface of large jobs, say machine tool bed, machine tool tables, say lathe bed, or say bed or table of planing machines, and so on. In a planomiller, these are also used in planomiller or in straight robust milling machines. The material uncoated or coated inserts, this kind of high speed steel are now obsolete. For nowadays all these face milling cutters are provided with clamp type carbide inserts, preferably coated carbide inserts, that will give you more productivity. It can be run at higher speed and can machine stronger materials. Now, use of next is form relief cutters. What is the characteristics of form relief cutters? Form relief cutters, say for example, say this is one tooth of a milling cutter. This is the configuration of the cutting tooth of profile sharpened cutters, where this is the rake surface and this is the flanks of primary flank, secondary flank. These are all flat surfaces. Okay. But in case of form milling cutter, this is Archimedean spiral, flank surface is Archimedean spiral, and when it is to be sharpened, then the material has to be ground here only. So, grinding or resharpening is done by grinding on the rake face only. These are the kind. The flank surface is Archimedean spiral. So, the distinguishing characteristics of, in contrast to profile sharpened cutters, what are the characteristics of form relief? Number 1, tool form is the replica of the job profile, that is number 1, just like gear milling cutters. Flank surfaces Archimedean spiral type as shown here. Resharpening is done by grinding the rake surface only, used for making 2D and 3D contour surfaces, not for flat surface. So, form milling cutters are not used for flat surface, they are used for making non-flat surfaces, not even say surface of revolution, it produces contours either 2D or 3D, say Archimedean spiral, this kind of have to be produced by 2D cutters, form cutters. 3D, say a die has got a cavity, this cavity has to be produced, that is done by 3D contour cutting tools. Now, you see the different types of form milling cutters. Form relief cutters simply called form milling cutters, say form cutter. Form cutters, these are made of high speed steel or carbide, normally high speed steel mostly, because the forms of the tools are very peculiar, you see, very complex shape. This complex shape cannot be attributed to carbides or ceramics, that is difficult. So, high speed steel can easily convert into such kind of complex shape cutter, but in some cases when this cutter is slightly standardized, then carbide tools can also be used, and if the cutting tools are very small in size, then solid carbide can be used to make it by the modern method. But anyway, these are made of high speed steel, especially occasionally carbide for very small tool or very large. What is it is producing? What are they doing now? See the applications. In this case, you see this surface is produced, this surface. So, it is like this. So, this kind of surface is becoming the product. So, this is the shape of the tool. Now, you want a surface like this, a groove. So, this is the shape of the tool. Now, this configuration of the form of the tool is a replica of the profile of the job wanted. Suppose you want to produce a V groove, but inclined, say like this, a groove like this. So, this cutter has to be like this. So, this is the cutter. It can be double V also. Now, again say the T slot cutters, in these machines, in some machines, various machines, T slots are there. These are called T slots. Okay. Machine tool beds are produced. Why? Because these are used for mounting the clamping bolts, T bolts, and this groove, this lower groove is produced by this kind of cutter. This is called T slot cutter. is also a form cutter. This enables production of this kind of grooves, and this is called long grooves are cut, called T grooves or T slots are cut. Next is gear milling cutters, a very common type of form milling cutters or form leaf cutters. Gear milling cutters, so we call gear teeth milling cutters. What is the material? Again is a form cutter, is essentially high speed steel. Very rare, you know, gear milling cutters are made of carbides. Only in case of very small module gears or small size gears, small cutters are required, and these cutters are made of solid carbides. Otherwise, these are made of high speed steel. Now, these gear milling cutters, here you see, this is the form of the tooth, two tooth. So, the material in between has to be removed by a cutting tool of this configuration. So, this cutter can be a disc type, here you see this form. So, this will produce the tooth gap here also, this type mounted on milling arbor, or it can be end mill type. Here you see this is end mill type. When the gear tooth are very large, that is the module is very large, and the gear maybe say 30 feet diameter or say 40 feet diameter, the teeth are say about 50 millimeter or 60 millimeter height, then this kind of cutter is used, end mill cutters. But even then, see the profile of the job, this is the involute. Okay. Now, this involute has to be produced by that kind of profile of the job, profile of the tool. So, profile of the tool, this is the profile of the tool, and this is the profile of the job. So, they are similar. It is a characteristic of form milling cutters. So, you can produce the teeth of gears, not only gears, teeth of say straight tooth spar gear, helical tooth spar gear, external, and then the teeth of worm wheel can be cut, the splines can also be cut. Okay. This has got various applications. Now, next is spline. What is spline shaft? Spline shaft, this is a shaft suppose. Okay. Now, for some time, for some reason we need some keyway for fixing, or it can be number of keyways. So, in this shaft there can be number of keyways on the forward side, or suppose like this, or it can be having some protrusion and there is a disc. So, this can slide axially, the disc can slide axially, but the rotation will be transmitted from this to that or that to this. This is called spline shaft. So, basically this is a rod, this shows a rod, suppose this is a rod of long length and this is the original material, the cylinder. Now, this portion of material has to be removed along the length parallel to the axis. So, this is the milling cutter which has got a particular form which resembles this shape, and this material removed after, and indexing this will be done one by one. So, this is another form milling cutter. Now, the tool form cutters, the form leaf cutters can be used to produce, suppose this is the drill. What is the drill? This is also a solid high speed steel rod. Now, this groove has to be made, this groove. You see that in drills, this is a drill. So, this is bounded by flutes, is not it? So, there are number of flutes are there. So, this flute, this flute. So, the grooves have to be cut. So, these grooves are cut by milling cutters. These milling cutters, this is a milling cutter, and the shape or form of the tool is exactly the replica of the groove. So, first this groove has to be made, then this groove has to be made. So, in this way different type of form milling cutters are used to make different types of flutes and different cutting tools like drills, reamers and milling cutters and so on. Now, thread milling. Now, these milling cutters can be used for cutting screw threads. I already mentioned, but how it is done. Now, here you see that short thread milling, long thread milling. Short thread milling means suppose these small bolts are to be made and the thread has to be cut here, okay, and huge number of pieces have to be made. These screw threads have to be cut, okay. This is done by this method. This is the cutter, okay. This is the cutter, okay, and this is the job. So, the cutter has got annular cutting edges and this is called gaussing. This gaussing is used to produce the cutting sharp edges and that will produce the thread. What are the motions? So, this cutting job will rotate slowly as it is done in single point chasing. The cutting tool will also rotate at relatively higher speed and then there will be motion like this. So, this will rotate and move in this direction slightly and that will produce the entire thread. So, this will be done very quickly, very fast production, and this is another example. Say long thread milling, long threads or long screws like say lead screws, feed rods, power screws or power press, this having large threads, okay, have to be made with a large depth and width. This is done, this can be done by single point tool, but it is better if you want to improve the productivity, this kind of cutter can be used, because the contact will be intermittent, the cutting fluid can be used which will be very effective, because instead of continuous contact like turning, this intermediate contact, this will allow entry of the cutting fluid for lubrication and cooling very fast, and here you can rotate the cutter faster. So, productivity will be high, force per tooth will be less and the cutting fluid action will be much better. So, this is long thread milling. So, some worms are also made, the hobs are also made by this long thread milling process by rotary cutting tool. This is also called rotary turning. Okay. Then other applications of milling, in addition to what I told, one for example is called straddle milling. Actually here suppose you want to produce this surface, this is already there, you want to produce this surface and this surface, these two surfaces, these two vertical surfaces at a given distance. Then you take one side milling cutter here, one and another side milling cutter here, suppose it is left hand type. So, this will be right hand type, okay, side milling cutter, and this will cut the slot here and here. So, this will produce surfaces like this. So, this vertical surface and this vertical surface. Now, gang milling, what is gang milling? This is also a fast product. Suppose you want to produce a surface like this, and this is called long surfaces. Okay. So, number of milling cutters are mounted tightly on the milling arbor and they will move simultaneously, they will rotate in the arbor and the job piece will move perpendicular to the direction or horizontally, and you get all this surface, this surface, this surface and this surface, all the surfaces together and along the length. So, this is very fast production. This is called gang milling. Now, I told you that turning operation by milling cutter. Now, this is the job, this was the original rod of large diameter of irregular size. Now, this is the finished diameter. What we normally do? We do in turning process by single point tool, where the tool and the job, the chip remains in continuous contact. Because of that, the tool undergoes very rapid heating and wear and tear. But in this case, instead of single point tool, we use a milling cutter or some milling cutter here, and that will give intermittent contact and the job will be produced. So, this will rotate in this direction, the tool will travel in this direction, job will rotate in this direction. So, this is called rotary tool. This is normally used when the workpiece is very large, very heavy and very odd shape, for which it cannot be rotated at high speed, okay, because of its odd shape and eccentric mass. But work has to be done faster with a large depth and feed. So, the job will be rotated in the faceplate in a lathe like machine, but the cutting tool will be a milling cutter. There are two milling cutters for balancing, or this can be a ring like having cutting tooth inside, milling cutters like, and that will do this turning operation, that is called surface of revolution. This is not very common, but for odd shaped jobs, and especially when you want to cut say screw threads or the outer screw threads, external screw threads on very odd shaped job. Suppose there is a very odd shaped job, here is odd shaped job, okay, and you have to cut threads here, then this kind of process is used, milling, thread milling cutters, rotary cutters are used for cutting the thread. Now, the ball nose. Now, this is a ball nose. Here you see the ball nose, the end is like a hemispherical. Now, this is used for machining free form 3D surfaces. Suppose there is a die, in the die you have to make a cavity, okay? You have to make a cavity for molding or injection molding or pressing like that. How this will be made? This will be made this kind of cutter. Suppose this is the cutter, okay? This is a cutter, spherical cutter, and this is the surface. So, this will be travel, this will rotate, and this will move along this surface by a program in CNC machine. So, these kind of tools are normally used in CNC milling machines. This can be high speed steel, or this can be solid carbide if it is small, or on this surface you can just fit one carbide piece by brazing here, and then you make it round on a carbon steel, or you can on the carbon steel you can mount number of inserts, carbide inserts. These inserts may be say coated type or uncoated type, all right. So, the materials will be both high speed steel or carbide. If carbide, solid carbide, this can be carbide blades if brazed, and carbide inserts, for example, this one either uncoated or coated. And lastly, you see that the milling attachments, the capability or the workability of milling machines can be further enhanced by using certain special attachments. For example, say you can see from books also that indexing head, all of you are familiar with this indexing head, which is used to hold job and rotate it to by given angle, say 30 degree, or divide into 20 pieces or 30, say for cutting the teeth it has to be rotated by 1/10 or 1/20 of the revolution and so on. This indexing head dividing head can be simple type, compound type, or differential type for depending upon the requirement. Horizontal milling arbor or the spindle, some attachment can be fitted which will allow this spindle, another spindle, to hold shell mill cutter or end mill cutter or space milling cutter, and then remain it vertical or to be tilted position for incline machining, or it can be tilted in this way also. So, about x axis it can be tilted, about y axis it also can be tilted, and this makes it very versatile. Now, internal slotting attachment. What is internal slotting attachment? Suppose you want, here is a disc, okay, and there is a hole already done. You want to make a slot inside. So, this can be done in a milling machine. Normally, it can be done in slotting machine or broaching machine, but in milling machine can also be done with the help of an attachment called internal slotting attachment. So, friend, thank you very much for today's lecture. So, next day we shall discuss about another kind of machine tool. Thank you.